hi everyone. Let's start with talking about Kotlin symbol processing and how to use it with common code. So I would like to introduce myself. I'm not only a lead mobile developer in tech software, and I also a mobile developer who used to develop both iOS and Android application in same time, so I'm full stack, and also I'm fond of cross-platform such as Kotlin Multiplatform, and I really happy that I am Kotlin GDE since this July. And also I'm fond of different activities such as speaking, writing articles, and so on, and also I'm a Woman Technic ambassador. So this all about myself, and now let's speak about Kotlin symbol processing. Today we will discuss how it works and what is Kotlin symbol processing. Many people know that Kotlin symbol processing was announced by Google this year, but no, not everyone knows how to deal with it and what for they need it. Also, we will see how to use it in practice, and I will show you some simple practical application of Kotlin symbol processing. I developed a small dependency injection library for Kotlin Multiplatform and presented it this year. But I was recommended by Jack Wharton to use some common injection pattern to make it more interesting, because manual dependency injection is not good for those who are developed dagger. So we will speak about how to use Kotlin symbol processing in dependency injection. And now we will speak about, yes, it will be some small introduction about Kotlin Multiplatform, because not everyone interested in this technology, and not everyone knows about how to use this cross-platform technology. But it's just a little bit introduction. The main part of my talk is about Kotlin symbol processing and its application. And speaking about Kotlin symbol processing and using it in multi-platform project, we should also speak about how to use it with iOS, because it's not supported, and how to support what is unsupported at the moment. So let's begin. Kotlin symbol processing, it is a technology to process annotations, and this technology is developed for several years, for a couple of years, but it was announced by Google in this February as a really nice and prospective alternative to Kotlin annotation processing tool. And this technology is compatible with Kotlin since version 1.4.30. And what is really interesting about this technology, it is one of its benefits. It is possible to use it with multi-platform projects. So this is why this technology was interesting for me at first sight. So what for we need Kotlin symbol processing, and what for we need annotation processing at all? First of all, we can use this technology to build lightweight Kotlin compiler plugins. So there will be no information about how to use Kotlin symbol processing to make some compiler plugins. It is just one of the alternative options and of the applications of this technology. We will speak about annotation processing. So it is really nice to use it with annotation processing, and it can easily and simplify your work with annotations. In this slide, I present you several annotations that I have used in my work with my library. So, and at first, let's begin talking about annotation processing. Let's make some small introduction. What for we need annotation processing at all? Many people saw annotation classes in Kotlin code, but not everyone use some custom annotation in their work. For many people who used to develop with Java, they know about such annotations such as override, suppress warning, and so on. that could be used in your code for analyzing it and to prevent some actions. So the first purpose of using annotation is to make it easy to analyze your code, to search for some marked with special marking. Annotation is just like a marking. Fields, classes, targets, and so on. Another purpose is to generate code. We can easily generate common code for really different purposes, and it is one way to simplify many abstractions in our code and to prevent us to write all this code by ourselves. How it works? Let's talk about some basics. So at first we need to register our annotation processing, and then we have some we have a list of our annotations, we have a list of our source codes, and we need to process all this source file for several annotations. So if we will find several annotations, the system, the processor will run, and if there is no annotations, we will compile our code, or the code with annotations will be processed. Maybe there will be several actions, or maybe it will be generation of several code, and all this generated code also will be compiled. For Kotlin, we use a Kotlin annotation processing tool. It is one of the main tools that we can use for processing annotations for Kotlin projects in Android, for example. When we use Java, we can easily use Java annotation processing. It's really nice to analyze, to modify existing code, to generate several codes. But with KAPT, we can only generate code that will be at the next iteration compiled with all our sources. How it works? The first version uses several data, and this data should be at first converted to several Java code. And there also was several processing stage that could turn all the Kotlin code in Java code, and this Java code then could be processed in Java bytecode. So there were several problems, and it took a lot of time. So on the next version of Kotlin annotation processing tool, for example, versions 2 or 3, they implement standard Java SR 269, and in this case there were a mechanism of using stubs, and also these stubs was connected with wrapped abstract syntax tree for these Java stubs, and then all this bunch of code connected with all our sources could be used with working with Java classes. So, and here is one of the most problems with speaking about KAPT. I'm sorry, I'm not really a specialist in using KAPT and how it works in its under. I only know the simplified circle of its algorithm. So KAPT had to generate Java code from Kotlin code. Also, it had to generate Java stub before compilation, and then we can compile all this bunch of code. So there is more code that we have written. Of course, when we're speaking about generation, we think that it will be several generated code, but it's not only what code, the code we expect to be generated, but also the code that expect to be generated in our code. So there is more code, and also there is more time for all our processing, and that is why KAPT is really slow. But KAPT is also effective, and it's really nice working solution, and we use it in all our Android projects. For example, when we use Dagger, it's also KAPT technology that helps us to generate all the bunch of code with all the stuff we need to work with our dependency injection solutions. Let's compare KAPT with Kotlin Symbol Processing. Though Kotlin Symbol Processing is an experimental technology, it's not ready to production, and the creators of this technology have written that this technology will be also prepared for production in some future, but not today. So why Kotlin Symbol Processing better than KAPT? Well, there is no need to use Java steps. We don't need to process our Kotlin sourcing in several Java code and generate Java steps. We can use the mechanism of Kotlin reflections to get and read the Kotlin abstract syntax tree and to receive all the information we need to process in our classes, and to analyze and to modify in several code that will be generated, not in our existing classes. And also it's compatible with Java code. That is why I like Kotlin. It's also compatible with Java code. And one of the benefits, it is a reason we don't need to use Java steps, and that is why it's faster. So it compiles rather faster, maybe 2 or 3 times than KAPT. It depends on your logic and your code. So let's pick how it works in basis. At first, there is several interfaces. Interface for symbol processor provider and the interface for symbol processor that will generate, analyze and generate all the bunch of code we need in our project. So here could be several changes in several signatures of functions in symbol processor, because technology is still be developed and there are several differences in different versions. So now in version 1.5 there is no need to use init in interface. So we had to implement these interfaces in our work. So, and also when we will be using our custom symbol processor provider, we need to declare it in resources section of your project, the same way you declare your annotation processor for Java. If you will forget about this moment, you will not receive anything. So it could be really problematic for those who not deal with other annotation technologies. When we implement our custom symbol processor, we can find that there could be several possibilities for us to implement the analyzing our code to processes for next purposes. For example, we can use our own generators, or maybe we can also specify some custom visitor that will implement KS visitor void class, abstract class, and there is several functions that we can use when we use our visitor. And also when you will implement your own generator, you also need to implement such functions that will get class declarations or function declarations and analyze it. So you can see that Kotlin Symbol Processing using reflection to get information about types and its components. So what we'll be doing when we will build our project? Project will read and analyze source programs and resources, and then generate code or other forms of output, and then we can compile all this bunch of code or maybe something else together with our sources. So it's really simple. And to make our work really easy, we cannot write all the functions in file with simple operations. We can use a really interesting and really comfortable and good tool, Kotlin Poet, that it's a really nice solution to generate source files. So here is several examples how it works. So there is several annotations with class type, type of functions, and so on. And in this really simple to construct your own classes, your own functions with your own parameters, and to put all these values, inject them just in this signature. So let's talk about how to create our own annotation processing. So at first, let's talk what are the limitations of using Kotlin symbol processing. Processors cannot modify existing code. Yes, we know it, and the same thing about Kotlin annotation processing tool. And it generates new files. But there is strong dependency on Java virtual machine at the moment. So yes, it's a solution for multi-platform, but now it depends on Java. And once again, it's experimental feature. So what means that it is experimental? It's not only that it is not ready solution for production. Several versions could be used in production, but it's not stable. When you migrate to next version, some things there is no guarantee that they will work. And what else? There is no enough documentation for different cases. I would like to present you several samples. There is Kotlin compiler playground. There is a solution that inspired me to make my solution more complicated because I have processed using other sample tools. But in this solution, you can find how to make multiple processors, multiple generations to work with complex objects. And when you use several injected annotations in several levels of your code. So, and there is nice and easy Kotlin symbol processing sample that is really good to start with. So, and now let's speak about my solution. I had my small dependency solution for multi-platform project. Here is the links to the library and to the sample. And I decided to, at first, so as Kotlin symbol processing works only with Java, I decided to use it with just my Android applications. So let's speak about what is inside of my dependency solution. It's manual dependency injection, and it uses several containers. There could be multiple containers in your application, and every container uses several resolver that get several objects, put in the scopes, scope it with different rules of living all these objects and classes and types, and resolve all these objects of several types, of course, according to the rules of scope. So, and how it works when we connect it in with our multi-platform project. So here is a simple solution. I have my common configurator, and this is configurator. I use several links, for example, for my special container. Into this container, I will put several types of my classes, of my services that I use in my work. And also I specify the fabric of initializator for every of these objects. So you can see that I use one service that depends on another service. So here is some injected dependency. So what we should do? It's really nice to simplify all this code with scope annotations and also for specific containers annotations and component scan. Yes, I saw the Kotlin compiler sample, but I use just a little bit another way to present my annotations and to present my generators. But it's a really nice basis for every hard project. So what we should do? We should create several projects. First, we will create in our multi-model project several modules for Kotlin Symbol Compiler and several modules for annotations. You can also specify your annotations even in your specific common code that you will use both for your native applications or maybe your symbol processing compiler. Why I connect my core, my multi-platform DI core to my compiler? Because I need several classes that I use in my work. So I need them in my compiler to know what are the types and how to deal with them. And what else? In my symbol processor, I need to connect Kotlin symbol processing. At first, it will be JVM, and in my dependency section, I also need to specify symbol processing API, and also to specify the source set for this library. Yes, it should be JVM, not forget to use it. And also do not forget to use Kotlin Poet in this model. It will help you to generate all the bunch of your files, of your code. And then how it will be working in my solution. Here is my symbol processor. It has several scanners that are my custom visitors, and these scanners searching for the several annotations I use in my work. And when they found several data, this data will be processed in several prepared for generation data, and then code generator will create my several classes that I need in my work. So let's organize your process just like this. So here is custom generators and custom scanners. At first, let's take a look in the main function process that use a resolver. And in this resolver, at first we need to search for our generated models and to scan all data and then generate all our models or maybe functions. It depends on what are you doing in your code. So and also not to forget to specify your processor provider that should implement your symbol processor provider. You cannot use only your interface. You need to implement it. And this processor provider should return your processor with several environment variables such as code generator and logger. So the main point of what is doing in your processor, in your symbol processor, is using resolver to get all the symbols with specific annotations you use in several parts of your code. Just like get symbols with annotation and specifying your annotation class with qualified name, then filter it with the class declaration, maybe function declaration if you need function declaration, and then you can also process all this data in the way you need at the moment. Also, you can just search and organize all this data and put it to create it in specific models, containers, and so on. So what should be done in generator class that will create the class with all the data you will specify to be generated? For example, you need using Kotlin Poet, and in this Kotlin Poet you need to use some kind of template. Yes, you should hard code some bunch of your codes. For example, package, import, and so on. Of course, you can find all this information by yourself, but it will be easy to specify it hard-coded if it is possible in several moments. Also, you need to specify such things such as default methods and default footers of your file. In this code, I will receive my container. It will be specific container with several bases, base dependency injection component. It contains all the bunch of code I need in my work with container, and also in my footer I specify several companion objects because I decided to use simplified architecture to test it, and so I'm going to use it with Kotlin native. That is why I use thread local annotation hard-coded in this footer. And when you will build your project, you will receive some kind of input if you will specify it with your logger. For example, I decided to use some kind of strange debugging to show me if I have found several annotations and several classes that are really sweet for my several annotations. So, and there is the result of my work. It is generated file. It's fully generated. There is no other formatting, and you can see that I received the same work I needed and I provided by default in my manual dependency injection. And also, you can see that I used my single. So I forget to provide you one slide. I think it is lost. But in this slide, there were several links towards annotations container upon network client class and upon the Movis service class. Movis service class using network client as a parameter in its initializer or its constructor. So you can see that system have found the network client class and resolve it as a parameter for my Movis service. So it works. And it's really easy to provide the injection in such way. Yes, I have really working solution with KSP. And here is the same class, but for those who just don't like the light theme. Well, you can see the ready-made solution with this link. So, and what else? It is not only just a generated file, it's fully a working solution. Here is my interactor I use in my Android application, and in this point I connect my specific container and just call resolve several class to use to get it from my container, and it works. I get it. So I decided to not to use it in my interactor because, of course, you understand that I had to use generated file, but I just want to use original file, and and that was not about using Kotlin compiler plugin to simplify work in such case. So Kotlin compiler plugin, it is just another story. So, and it works for Android. Yes, it's really a working solution dependency injection with Kotlin Symbol Processing. So now let's use it in multi-platform project. What is Kotlin Multiplatform Mobile? It is not only it is a multi-platform SDK by JetBrains company that allows you to provide some common code in your common module, and this common module will be compiled in specific frameworks or library that is supported by iOS and Android. And also you can specify the most of your code to be common. It's really nice to simplify your work, to make common business logic and to use it separately for Android and iOS native applications, and just provide UI as in different implementations. So to make Kotlin, working with all these platforms, Kotlin Multiplatform use different versions of Kotlin. For example, it will be JVM for Android, and it will be native Kotlin for iOS, and also GS for Kotlin GS. And what else? KSP is working with Kotlin GS, and if your solution use only JVM and GS and no iOS, there is no specific work for you. You just need to connect your library as a common dependency in your project. So there is the schema how the models are connected in my project. So I use several common models. It is common core model and common shared model. Common core is my library, and here is also native and iOS and Android applications connected with shared model, but not with core. And how can we connect our KSP, that is JVM library, to this shared model? We cannot connect it to common main because it contains JVM, and our common main contains different targets. So we have to connect it to JVM or Android main. So in this case, we know that if we will connect it, why we cannot connect it to common main? Once again, because when we will receive several problem outputs, that our work is not compiling at all. Yes, Kotlin native will be supported by Kotlin Symbol Processing, but not now. It is official plans of development stage of roadmap of this solution. So at the moment, it is not supported, but we need to use it with Kotlin native. So I decided to use it. I like challenges by myself. So if we will connect our Kotlin symbol processing, and then, yes, hope there is no tomatoes. If you will connect your library and then you will specify, you need to KSP your project in your KSP your multi-platform project, you will receive oh no, there is some problems. So you will receive really not good output, that it's not compiled with your ARM and x44 64. I'm sorry, iOS. So it's not supported at the moment. So there is a bunch of information about unsupported targets. But we would like to use it in Kotlin Multiplatform. So to use library with Kotlin Multiplatform in common way, we have to use it to make it multi-platform. So we need to create multi-platform library for our multi-platform project. And then we turn our compiler to several multi-platform compiler. I call it KSP DI shared, and it's not now. And now it is not JVM. It is multi-platform, and also it uses Java library to it work. So, and also I need to specify just JVM main target in my Kotlin Symbol Processor that will be a multi-platform library. Then I have to connect it with my shared model. And also it will have a link to my core to use it in work. What about annotations? Perhaps you don't need it. You have to specify it in core. It will be simple because all the parts of your project will receive the access to your annotations to read them and process it in what way that this part of your code need to do. So, and what should be done in our shared model? Here we should connect our KSP the same way we use in our native application. Also, we have to specify the link to implement and to process as KSP to our shared library. it should be done in dependencies section, not in common main, not in Android main, not in iOS main, only in this low section under of this Kotlin section. And now, well, once again, we remember about all these problems. So here is what should be generated when we will build it with our Android target. Yes, it works as shared model. It works with Kotlin Multiplatform shared model, and in this part we will receive our generated file. It's really cool, and it is the same file we have received in Android application before. So now let's make it work with the iOS. So yes, it's really experimental, and it's experimental feature. Yes, it's in alpha now, and there is several releases that could be in alpha and in beta, but it still be experimental solution, and so it will be kind of experiment to work with the Kotlin native and iOS. So let's take a look in our file. It is a common code that we can use in our common project because it is designed as common code for our project. And how we can use all this code that in with our native applications. We know that we can connect our library as a separated source without any need to compile it or recompile it. And also we can put all the bunch with our generated common code. Yes, there should be several work from the command of Kotlin Symbol Processing to make it in one common library. But let's now work in its moment. We can specify the way, the path to our generated classes. Of course, if you use different build variants, not only debug, you need to specify it both for debug and for release. And you should specify only one path, because when it will be generation processing, the same code will be regenerated and overridden. So it's enough to specify common main to be used with both iOS and Android and common code. And in this case, when we build our solution, it will be working with our iOS applications. Of course, at first sight, it should be regenerated before you will get before it will be available to you to use this code in Kotlin native iOS site. So if you will clean everything in your common code and then you will recompile it with iOS, and if you're working with bounded projects, you will receive no inputs, you will receive only an error. So it will be a problem to compile your framework for your iOS application. So, and in this case, you need to build data before. So now it works the same way we have to use in Kotlin Multiplatform before, when we have no abilities to recompile our libraries for iOS automatically from iOS site. But it's really working solution, and I recommend you to test it. So what are the challenges with the Kotlin Kotlin Symbol Processing? Nowadays. Yes, it works with multi-platform, but not working with Kotlin native without any other actions from our side. Generated files are not used by default. We need to specify the path to these files to be used in our multi-platform or our Android applications. And it still be experimental feature at the moment. Yes, it's really prospectful, but it's currently experiments, so you know that all the risk you take by yourselves, and there is no guarantee at the moment when there is no stable migration from one version to another. And there is lack of documentations, but there is several working samples, such as Coin or maybe KSP, or also there is nice solution to generate stores with Android and live data. So what could be an alternative when we generate our code? If we need to modify existing code, we have to use compiler plugin. And these solutions could be used in Kotlin native, but there is no part in my talk today. It's another story, and if you are interested in how to use KSP as a Kotlin compiler plugin, or maybe other technologies to use it in creating compiler plugin, you can find it by yourselves. So, what are the future prospects of this technology? In the official GitHub, there is information that it will be supported, that Kotlin Native will be supported by Kotlin Symbol Processor, and the IDE will find all your generated code automatically and will help you to deal with it. What else? And let's summarize our talk. I hope it will be interesting for you. If it was interesting for you, give me some reactions. I would like to see it. Okay, Sam, thank you. So yes, Kotlin Symbol Processor show us the better performance. If you will try to make the same actions with KAPT and KSP, you will find that KSP compiles faster, and so there is less of a bunch of generated code that will be used in your work. So yes, it's experimental, but it still be developed, and it's really prospectful. So though there is no recommendations for how to use it in production at the moment, you can find and use it in really interesting cases. For example, Room or Moshi uses KSP. And well, it's multi-platform at the moment, but it doesn't support Kotlin Native, but it will support Kotlin Native and multiple rounds in future. So it's really nice. Here is several sources. The first source is my playground. Also, there is Coin compiler playgrounds. I think it's really a good solution. It's best sample I found. And the last link is core library that also shows KAPT how to deal with generation and to use not supportable technologies with Kotlin native and iOS and multi-platform libraries. So thanks for listening. Here is my Telegram. Here is my Twitter. Subscribe at my Twitter. Thank you very much. I'm ready for questions if we have time.
Yeah, that was a really insightful talk on KSP. We do have some of the questions around, so I'll bring them on the stage. You can answer them directly. Yeah.
What about tab collisions with the iOS platform during the code generation? Well, the main point when you generate your code, it have to be those kind of code that is common code, or you need to specify in the Kotlin native part several implementations with expect actual, and it will be compiled automatically in the bunch of code that will be used for in your Kotlin native site. So in this case, that there will be no collisions. Of course, you have to think about such moments as seal class with inner class, with nesting, and so on. What is not supported with the iOS and Kotlin native, you shouldn't use in your work. It have to be in your Android site, or maybe there have to be no such code in your work.
All right. Thank you. So there's another question over here.
How community can contribute to the process? There is an instruction, there is some guide, in GitHub of Kotlin Symbol Processing that will help for those who are interested in contribution in Kotlin Symbol Processing, to become a contributor, you can find it in specific page of the GitHub of Kotlin Symbol Processing.
So there are many requests coming up. So are you sharing the slides on slide deck or on your?
Yes, I will provide it so I can share it in chat. I have prepared it. So there was a question about how to generate dictation code. Yes, just you have to maybe, well, it depends of what template you would like to implement and how you would like to how you would like to specify your annotations and several parameters. If you will analyze it as you have specific functions, specific variable properties, and you will implement the generation it in your templates, it will be working even with an extension. But remember, it will be working only with Android, because iOS, if you will speak about Kotlin Multiplatform, doesn't support extensions in Kotlin. So I will share my slides in chat.
Sure, sure. Yeah. Thank you, Anna, for the wonderful talk.
Thank you
Hopefully,
very much for such opportunity. I'm really happy to be here and to speak with Android Worldwide Meetup. Thank you very much.
Thank you. Bye.